Okay, today we're looking at lines that are either parallel or they're perpendicular. In other words, one is at right angles to the other. If the two lines are parallel, say y equals 2x plus 1 and y equals 2x minus 2, you notice that their gradients have to be exactly the same. So parallel lines, their gradients must be exactly the same. Now for perpendicular lines, so say for instance this other line, y is equal to minus a half x minus 1. What actually has to happen is that the product of their gradients has to be equal to minus 1. So if we go 2 times minus a half, we'll get minus 1. So we can either say that the product of the two gradients is minus 1 if they're perpendicular, or what we can do is rearrange that to say that one of them is minus 1 over the other gradient. That's what we call the negative reciprocal of the number. Okay, so let's just say that one of the gradients was 4. If there's going to be a line that's perpendicular to it, the other one has got to be, so that was positive, so this one needs to be negative. That's like 4 over 1, so this other one has to be 1 over 4. So we change it from a positive to a negative, and if that's 4 over 1, we flip it to be 1 over 4, and then those two gradients will be perpendicular. Similarly here, if we've got minus 2/3, the other one, so if this one's negative, the other one needs to be positive, and we flip that over, so take the reciprocal to get 3 over 2. Okay, we've got a line which is parallel to y equals 3x minus 1, and it also passes through 0, 4. And if you think about it, 0, 4 is actually going to be the y intercept. So if we're parallel to this line, we've got to have the same gradient, so we know that m has got to be 3. Here we're told that b is equal to 4. So we can now just say y is equal to mx plus b, so 3x plus 4. Example 18, find the equation of the line which is perpendicular to the line y equals 2x minus 3. And again we're given the y-intercept is minus 1, so b is equal to minus 1. To work out the gradient we need, so we're told that m, so the gradient of the first line is 2. So the line which is going to be perpendicular to that line there, so if that's positive, this one needs to be negative. That's like 2 over 1, so we just take its reciprocal to get minus a half. So we know the y-intercept, we know the gradient, so y is equal to mx plus b. Okay, we need to decide whether these equations represent parallel lines or not. Okay, so for the first one, the gradient is going to be 3. For the second one, the gradient is also equal to 3. Since the gradients are equal, then yes, they are parallel lines. Okay, for part C, we've got the first gradient there is equal to 7. The second gradient's equal to 2. They're not equal, so no, they're not parallel. And part E, we've got the first gradient being equal to a half. The second gradient is equal to minus a half. Again, they're not the same, so one's positive, one's negative, so they're not parallel. Okay, we're given the gradient of one line. We need to work out the gradient of any line that's perpendicular to that. So this one here is positive, so the second gradient needs to be negative. This is like 5 over 1, so we just need to take that reciprocal. Okay, for part C, the first gradient has got a negative gradient, so the other one has to be positive. This is like 3 over 1, so again we take that reciprocal there. Okay, if we need to work out whether two lines are perpendicular, just multiply their gradients together and see if they're equal to minus 1. So here we've got the first gradient is equal to 4, the second gradient is equal to minus a quarter, so m1 times m2, that's going to be equal to 4 times negative a quarter, which is equal to minus 1. If the product of the gradients is negative 1, then yes, they are perpendicular, and you can just write that sign if you don't want to write it perpendicular. Okay, the next one, look, at a glance we can tell they're not, because you can see they've got the same gradient. So we've got m1 equals minus a half, m2 is also equal to minus a half, therefore m1 and m2 are not not perpendicular. The reason for that is that they've got to be parallel. Okay, if the gradients are the same, they're parallel, they can't be perpendicular. Okay, so in each case we're given a line. We're given a what's actually a y-intercept in each case, because the x value is 0. Now we need to find the equation of each line through each of these points parallel to each of those. So we just take the gradient from the first line they give us, the y-intercept that they give us, and so the line we want is just going to be 2x plus 1. So in other words, we have the same gradient, so they're parallel, and it passes through there. Similarly, m is equal to minus 1 here, b is equal to 5, so we can say y is equal to minus x plus 5. We've got m is equal to 2/3, b is equal to minus 5, so y is equal to 2/3 x minus 5. Question 5 is similar, but this time we want the new line to be perpendicular to this line here. So the new gradient needs to be the negative reciprocal. So if this is positive, the other gradient needs to be negative. This is like 3/1, so we take the reciprocal of that to get minus a third. The y-intercept again is given in the question, so the new line will be y is equal to minus 1/3 x plus 3. Similarly here, this one's negative, so the new line is positive. This has got like 2/1, so we take its reciprocal. b is equal to minus 4. So we get y is equal to a half x minus 4. Again, this is negative, so that becomes positive. The reciprocal of 7 is 1/7. b is equal to minus a half, so we get y is equal to 1/7 x minus a half.